Good evening, बच्चों. Welcome to our channel Fundu Physics Fundu Physics Fundu. Today's lesson is starting the Newton's laws of motion. Newton's laws of motion. Newton's laws of motion. Recently, we have completed the kinematics. Just recapitulate about it. What is kinematics? There's a motion of a particle or a body. Motion of a particle or a body. Just discuss about the motion of the particle of the body, not about what causes do it. But here in the Newton's laws of motion, we have to discuss about the external agency that creates the motion and the behavior of the external agency. That is the basic difference between the kinematics and the dynamics. So here we have entered to the arena of the dynamics. We have entered into the arena of the dynamics. So you have to study it minutely to solve all kinds of problems in the NEET or the JEE Mains, and it also covers the basic concepts. Now before we start the Newton's laws of motion, we just discuss about the frame of reference. Frame of reference. What is frame of reference? Frame of reference may be an object or some axis or the group of axes in a reference to which we can describe the motion of a particle or an object. We already know about the 3-dimensional coordinate system, that is x-axis, y-axis and z-axis, and O is the origin. Let flying in the space, reference to which we can describe its position, velocity, acceleration and momentum and so on. So from that we have understood that with respect to the frame of reference we can describe its position, velocity, acceleration and motion and so on. So all the physical quantities can be described with respect to a frame of reference. Now we have understood about the frame of reference. Now there is two type of frame of reference. Number one is the inertial frame of reference and non-inertial frame of reference. Non-inertial frame of reference. Non-inertial frame of reference. Now what is inertial frame of reference? Let us consider these three fingers perpendicularly extended to each other. Now this frame of reference, let us consider this is x, y and z. It is at a point constant, at a position constant or moving with the uniform velocity. Well, if it is moving in the uniform velocity, there is no acceleration. So that kind of frame of reference is called the inertial frame of reference. What we learned, number one, the frame of reference is at rest, or number two, frame of reference is moving with the constant velocity, and number three, there is no acceleration. As there is constant velocity, so the acceleration is zero. Now, what is the significance of this of inertial frame of reference? All the laws of motion, Newton's laws of motion, are described in the inertial frame of reference. Let us take an example. Newton just sitting underneath the apple tree, and the apple is coming down from the tree towards the earth. That was the inertial frame of reference. Newton is the inertial frame of reference, or the earth is the inertial frame of reference, and the apple is falling. Apple's position, velocity, and acceleration can be described with reference to the Newton, or with respect to the earth, or with respect to the apple tree. Those are the inertial frame of reference. Now, the Newton's laws of motion exist in the inertial frame of reference. But non-inertial frame of reference, there is the acceleration. There is accelerated motion. Accelerated motion of the frame of reference is called accelerated motion. Is called the non-inertial frame of reference. In the non-inertial frame of reference, there is no existence of Newton's laws of motion. This is the basic difference, and we have a question about it: in which frame of reference the Newton's laws of motion exist? That is the inertial frame of reference. Now let us consider an example, a frame of reference. That is, let us take an aeroplane moving with the acceleration, and I am sitting on the earth. A traveler in the plane looking at me. I'm accelerating I'm also accelerating, but in the opposite direction. So the plane is moving with the acceleration in the positive direction, but I am moving in the backward direction with the same acceleration. So I see the plane accelerating. This is a non-inertial frame of reference, but a traveler sitting inside the plane, he or she also see me. The traveler see me that I am accelerating in the backward direction. That is, with respect to him or her, I am the non-inertial frame of reference. So we have all concepts about the inertial frame of reference and the non-inertial frame of references. Frame of references may be of the Cartesian coordinate system, or the cylindrical coordinate system, or the spherical coordinate system, so on. And it also the curvilinear coordinate system. Now let's move towards the Newton's laws of motion. Newton's laws of motion. What was the statement of the Newton's laws of motion? Every body continues in its state of rest. State of rest means it is marker pen. Just here I put it here, and it is not moving with respect to time and the other objects surrounding it. That is at the rest position, or the uniform motion in straight line. The marker is moving uniform motion with the uniform velocity, moving in a straight line unless compelled by an external force to change that state. But there is no external force. If there is no external force, it continues its rest and the motion along the straight line, uniform motion along the straight line. That was the Newton's first law of motion. Now here we have discussed that every object on the earth tries to retain its initial state tries to retain its initial state. What is it? That is the inertia. That is inertia. That is inertia. Now, by virtue of which every object tries to retains its state. Now, inertia can be divided into the three subparts. Number one, the inertia of rest. Inertia of rest. Now, second is, what is second? Rest here. So there is motion. Inertia of motion. And third is the inertia of direction. Inertia of direction. Inertia of direction. Inertia of direction. First one is the inertia of rest. Let us consider a plane on which a wooden block has been kept. It will continue its state, but we are trying to moving it. It tries to be at rest. This is called the inertia of rest. A body or a wooden block moving along a straight path with the uniform velocity. If there is no external force, it will move along the straight path with the uniform velocity. If there is a force, external agency, this is a force, but it tries to move along the straight line with the uniform velocity, that is the inertia of motion. Now the new term is the inertia of direction. What is inertia of direction? Let us consider an example. We are sitting inside the bus, and the bus is moving with the uniform velocity. Now there is a turn. In front of the bus, and bus gets turned along the path, but we certainly moves in a definite direction at which we are moving initially. So to keep the direction of motion, that is the inertia of direction. Or I will take another example. Or I will moving on the muddy path. It is extremely muddy path. When the wheel is moving on the muddy path, the mud will be deflected along the tangent of the wheel. This is also the inertia of direction. Okay. Now let's move to the another concept. It's a beautiful concept of linear momentum. Concept of linear momentum. It is a straight path, a body or ball. Let us consider here a ball is moving along the straight line. Its mass is m and its velocity is v. So the linear momentum equals to m into v. Now transform it into the vector form, that is p is equals to m v. That is the equation. P equals to m into v. Now find its unit. How to find this unit? This is mv. Now SI unit. SI unit of mass is kg, and the SI unit of velocity is meter per second. So kg meter per second. And what is this dimension? Dimension is m, mass is m, and the velocity is L t inverse. Right, students? M L t inverse. Now, as it is totally involved with the velocity, velocity is a vector quantity. We have also known that the velocity is a velocity is a vector quantity. So the linear momentum is also the vector quantity. Vector quantity. So now here we have P, that is the linear momentum, equals to m into v. We draw three graphs regarding this. P, that is the linear momentum, versus velocity, where mass m equals to constant. Right? Now second case, P versus m, where velocity is constant, and the third one v versus m, where p is constant. Now here p equals to m into v. We draw the graph P and V, P versus V. Now here, if M is removed, then P proportional to V. So here Y is proportional to X, straight line passing through the origin. That will be like this. O is the origin. That will be like dash. Again V is constant. So P is proportional to M. So again that straight line passing through our origin. Now next one P equals to mv. P is constant, so m proportional to 1 by v, that is the xy equals to constant, that is rectangular hyperbola. Now let's move to let's take two example. Or question. Let's take two questions. A car and a scooter. Problem. A car or a scooter are traveling with the same speed. Now, which of the two has greater momentum? Now, which of the two has greater momentum? That is linear momentum. So here we take that the mass of car is equals to mc, and mass of scooter is ms. So easy question. That is an easy question. and the linear momentum is pc for the car, and for the linear momentum for the scooter is ps. Now we know that p is equals to mv. Here v is constant, so we can write for the car pc is equals to mcv, and for the scooter ps equals to msv. Now take the ratio of them, we'll get pc by ps is equals to mcv by msv. V will cancel out, so we have this, and the mass of the car must be greater than mass of the scooter, that is greater than 1. So we have pc by ps is greater than 1, so we have pc is greater than ps. pc is greater than ps, which is the answer. pc is greater than ps. Now let's move to the Newton's second law of motion. Newton's second law of motion. Second law of motion. Now what it states? It states that the force applied on a body is directly proportional to the rate of change of momentum, and in which direction the force is applied, a rate of change of momentum will takes place in that direction. That is the Newton's second law of motion. Now to get the formula for force, formula for force. How to find it? Here is described that F is proportional to rate of change of momentum, dp by dt. We have dp by dt. dp by dt. Now F is equals to k is a constant, dp by dt. Now if F is 1, dp by dt is 1, then k should be 1. So the formula is F is equals to dp vector by dt. Now here we can convert it into the velocity. Let's take it. Okay. Now F is equals to d dt of mv minus mu. What is v? V is the final linear velocity and u is the initial linear velocity. Now getting out the m is constant, so d dt of v minus u. D dt of v minus u, what about, we know that is the rate of change of velocity, and rate of change of velocity is the acceleration. So F is equals to ma, F is equals to ma, which is the formula for the force, F equals to m into a. Now the units. Now the first we discuss the dimension of the force. Dimension of the force. Dimension of force. Dimension of force. F is equals to m into a. The dimension of mass is caps m, and acceleration is L t to the power minus 2. That is m L t to the power minus 2. Which is the dimensional formula of the force. Now the unit of force, units of force, units of force. Number one is the absolute unit, absolute unit, and number two is the gravitational unit. Gravitational unit. Number one is the absolute unit is the Newton in SI unit, and in CGS that is dyne. And what is the relation between them? 1 Newton equals to 10 to the power 5 dyne. Now the gravitational unit. Gravitational unit is also divided into two parts, in the CGS unit and SI unit. CGS unit is gram weight and the SI unit is kg weight. Now 1 gram weight is equals to 980 dyne and 1 kg weight is equals to 10 Newton. That is the relation. Why I have said it? Because we have to use this in the numericals. We have to use this in the numericals. We have to use this in the numericals. Now let's move to the impulse. Now it can be written like that: J equals to F delta T. It can be written like that. And what is the unit of the impulse of force? Now what is the unit of the impulse of force? Unit of impulse of force, F equals to, we know that J equals to F delta T, right? That is F equals to M into A into delta T, right? Now SI unit is, F is kg and acceleration unit is meter second to the power minus 2 and that of delta T is s. So we have kg meter second inverse, kg meter second inverse, kg meter second inverse. Now what is the dimension of it? Dimension, there's a force dimension is m l t to the power minus 2 and delta t is t. So we have m l t to the power minus 1, ml t to the power minus 1. Now let's move to the impulse momentum theorem. Impulse momentum theorem. From the Newton's second law of motion, we know that F is equals to dp by dt. We have already noted that. So dp is equals to F dt. So dp equals to F of dt. Now the momentum, integrate it from P1 to P2, dp is equals to F dt integration T1 to T2. T1 to T2. Now integration T1 to T2. Now we have, that's the integration T1 to T2 F dt is equals to P2 vector minus P1 vector. P1 vector. we can also integrate it. F integration t1 to t2 dt is equals to p2 minus p1. So f t2 minus t1 is equals to p2 vector minus p1 vector. So f delta t is equals to p2 vector minus of p1 vector. Now that is the all for the day. Please share, subscribe and comment, because your comments are valuable for us to improve the channel programs.